Hi, I'm Ms. Bong. Today we'll be solving simultaneous linear and quadratic equations. So what do they look like? There will be equations that have one solution, two solutions, and no solutions. When it's one solution, it's when the two graphs just touch. When it's two solutions, it's when they cross, and our solutions are the intersections. And no solutions is when the graphs don't touch at all. This one has a special name. It's called the tangent. Example 1. Find the point of intersection of the parabola with equation da-da-da and the line with equation da-da-da. Let's do it. So the intersection means equate. So we let the two equation x squared minus 8x plus 12 equal the other equation minus 3x plus 6. And all we have to do is solve. So bring the x squared stays there, bring the minus 3x to the other side, becomes minus 8x plus 3x is minus 5x, then 12, and then minus 6 is just 12. Now we factorize and we have 2 and 3. So now we get x is equal to 2 and x is equal to 3. So what do we do about these two things? We can find y. So when x is 2, what will y be? I can plug it in any of the equations. I'm going to pick linear because it's a lot easier. So plugging x equals 2 into the linear equation, we have minus 3 times 2 is minus 6 plus 6 is 0. And then the 3 minus 3 times 3 is minus 9 plus 6 is minus 3. So we have the 2 points of intersections as 2, 0 and 3 and negative 3. And it looks something like that. 2, 0, 3, negative 3. So we can also use the calculator to work it out. So let's bring up our calculator. So we first of all click on main and then click on keyboard, which is down here. Then type in that, find that button there, which is right there. And then in each of these boxes, you're going to type in the equation. So y equals x, use that symbol for squared, and then minus 8x plus 12, and then the second equation goes in the second line, y equals minus 3x plus 6, and then we have to tell the calculator what do we want. So in this last little box, we type in x, we want x, and we want y, separated with a comma. The comma is here. Then hit enter, and ta-da, we have x is 2 and y 0, so that's our first point, and x is 3 and minus 3, which are our second point. Let's use a little bit of algebra to see if there are any patterns. Now if we equate the line y equals mx plus d and the parabola y equals x squared plus bx plus c, we have that monster of equation there. But what do we notice? We notice that this gives us the quadratic equation. Hence we can conclude that a line can meet a parabola in at most 2 points. See, this is a quadratic equation. The highest power is x squared. So the line can only meet the parabola at most 2 points. Remember, we can only have 0, 1, or 2 solutions. If the discriminant of the resulting quadratic is negative, the line does not meet the parabola at all. So the discriminant where b is this, a is this, and c is that. If the discriminant of the resulting quadratic is positive, the line meets the parabola in 2 distinct points. And if the discriminant of the resulting quadratic is 0, then the line is tangent to the parabola. Example 2. Prove that the parabola with the equation y equals x squared minus 7x plus 10 meets the line with the equation y equals minus x plus 1 only once. So the intersection means equate. So let's equate things, let them equal to each other and solve. So minus 7x and then plus x is minus 6x, and 10 minus 1 is 9. And then we know that's a perfect square, so we have x minus 3 squared. And the discriminant is, that's b, That's A is 1 and C is 9. We can work that out as 36 minus 36, which is 0. So we can see that it's going to give us one solution. So the solution is that x equals to 3. Now we're substituting to find y, and of course we pick the easier equation. So 3, when x is 3, y is minus 3 plus 1 is minus 2. So the point of intersection is at 3 minus 2. So the discriminant helps us see that we only have one solution. Thanks for watching. I'll see you next time. Bye!